Welcome to Parasitic Diseases. Today we're going to discuss Giardiasis. This is an infection caused by Giardia lamblia. It was originally discovered in the old times of microbiology. I will tell you when it was discovered, and perhaps you'll know this person that actually was responsible for its first description. But it was named by Stiles in 1915. So where is Giardia found? Giardia lamblia is found throughout the world. There is no place that people live that Giardia has not been found. So that tells you something about the universality of this parasitism. And it doesn't tell you how it's acquired, but it gives you a hint that it may either involve food or water, because those are the two essentials that we can't live without. Its discovery was credited to two people. First, Anton van Leeuwenhoek, working in Holland, actually developed the handheld microscope, which utilizes a hanging drop of material. It has to be aqueous for him to look at it. And indeed, one day, I don't know why, he was perhaps bored with looking at pond water all the time. He just decided to look in his own stool. You'd have to ask Anton as to why he actually decided to do that, but we're lucky he did, because what he found there was Giardia lamblia. And he described their motion somewhat poetically in Dutch as these little organisms that sort of float like leaves as he watched them move about as the result of their flagellae, because they're flagellated protozoans. Sometime later, Willem Lambel is given credit for making very accurate drawings of these protozoans. And so therefore, the last name of the organism, Giardia lamblia, reflects the fact that he contributed a lot to our knowledge of this protozoan parasite, which is so universally accepted by the human host. So let's see a little bit about this parasite. First of all, it's a single cell because it's a protozoan, but it's one of the few protozoan parasites of humans that actually has more than one nucleus. And they're both transcriptionally active. So you see here depicted those two nuclei very nicely in this sample of stool that was taken from an infected patient. Here is the pointer on both of those. You can see the flagellae, although they're harder to see, they're still there. And then finally, if we move on to the other form of this infection, so there are two forms of this infection, we see now that it has another rounded up, non-flagellar type of entity, which we will call the cyst. This is able to resist the outdoors. So if we were to defecate in the woods, and if there had to be a freshwater pond in the locality that we did that in, this organism would be able to survive in that situation for some time, so that it could then be transferred to another animal. In this case, Giardia, the trophozoite, is not infectious for another animal, but its resistant stage, the cyst, is. So this is an interesting pattern that this protozoan has developed in order to spread from one place to another. And that's probably the reason why it's been so successful throughout the world. Recently, we've been able to culture this parasite, and here are three very happy-looking trophozoites. And these trophozoites have specific growth requirements, and in fact, they grow best under anaerobic conditions. While they can tolerate the presence of oxygen, they prefer an anaerobic environment, and all of the byproducts of their metabolism are anaerobic-like products. Fatty acids, for instance, and noxious, gaseous elements like methane are produced as the result of their in vitro culture. So the life cycle is very straightforward. We consider this a direct life cycle, meaning one parasite spreads to another host, and it doesn't involve anything else except the environment to get it there. So we see that the cyst stage starts first, and I'll use the pointer to show you what I'm talking about. Here we go. And this cyst stage has 4 nuclei in it, and we swallow it. goes to the small intestine, and it excists. And from each quadrinucleate cyst, we can produce 2 trophozoites that are binucleate. And these trophozoites, because they're in the right place, can now stick to the surface of columnar cells. And when they do so, they use a protein, which is referred to as giardin, but there was another term for this before that. It was called taglin. Those are the same substances, just brought up to date. This organism can then divide by binary fission to produce multiple copies of itself. As I'm indicating with my hand, the organism can actually grow to confluence over the entire villus surface. This has consequences for the host, but we'll come back to that in a moment. Sometime during the replication cycle of Giardia, they switch development from the trophozoite stage to the cyst stage. Each trophozoite can round up as a developmental stage. The nuclei then undergo one replication cycle. All of the organelles collect in very unusual inclusion bodies. A hard, environmentally resistant layer is created on the surface, and this is the stage that then passes out in the feces and contaminates the environment and begins the infection again. When these parasites gain control over our villus surface by simply covering them over, pathology results. It's called malabsorption syndrome. And that results in a flattening of the villi. If these are the normal villi over here, you can see by comparison, these flattened villi, they have a reduced surface area. As a result, the things that you ingest that would ordinarily be absorbed there are not. They then transfer down into the large intestine. A lot of these substances include all of the fats that we ingest. So we end up with a diarrheal disease called steatorrhea. It's foul-smelling, fetid, just it's unpleasant to be around someone who's infected with Giardia. Let's just put it this way. Now, sometimes when a person comes in and is diagnosed with malabsorption syndrome, other diseases are thought of, and including Crohn's disease. When the biopsy is taken to diagnose Crohn's disease, they found out that indeed they didn't have Crohn's at all. Rather, they had an infection of Giardia lamblia. And you can see one of those parasites shown here. Although you wouldn't be able to recognize this as Giardia, a well-trained pathologist can tell you exactly what that represents. And the diagnosis is made, and then we can go on with the treatment. Here's a good example of the way Giardia looks from one of those biopsies that were then transferred over to the electron micrograph phase by freeze fracture. And you can get a nice surface view of what this looks like in terms of the sort of a bird's eye view of what it's like to be a Giardia parasite in the intestine of your host. So how does all of this disease come about? And it's mostly by the parasite simply excluding the absorption of fats. And as a result, of course, if this occurs in children, this could actually slow down their rate of growth. And in fact, it has been associated with failure to thrive syndrome. And that is a problem in most of the developing world. But we have a way of combating this organism. It isn't all one way. So if your immune system is intact and the organism eventually starts to impinge on the secretory immunoglobulin pathway by giving off enough antigenic stimulation to allow those antibodies to be formed to begin with, then we have a robust response that occurs, and in several weeks, perhaps, the organisms now encounter antibodies, which prevents giardin from actually adhering to the surface of those epithelial cells. As a result, they're dislodged, they're displaced, they move down into the large intestine, where the essential niche is not represented, and they disintegrate and die. And eventually, of course, they go away. So most people that acquire this infection are able to fight it off by themselves without the use of drugs. It's unpleasant, as I mentioned, but still no problem. But what if you're one of those people that can't make secretory IgA and can't move those piece proteins to make dimers out of those IgA molecules? What if you can't do that? Then what about for you? What would this infection look like? And the answer is it would be prolonged, and it may never go away. It may become a chronic infection. At that point, you become almost like a carrier, and you are a source for that infection for other people. And for that, another reason why this parasite is so successful. So, taken together, we have diarrhea, we have weight loss, constipation occasionally, which seems like, why would there be constipation when there's diarrhea? And of course, that relates very much to what's going on in the small intestine at the time. And then because all of this takes its toll on your immune system, you start to feel tired. And now Dr. Daniel Griffin is going to give a clinical vignette illustrating the pathogenesis of this infection.
This is a woman in her 30s who comes in to be seen with a chief complaint of diarrhea in an outpatient clinic in Colorado. She reports that she is having foul-smelling loose stools multiple times each day, stomach cramps, nausea, and gas. She reports that symptoms were most severe for the first few days, but although they improve, they are persisting. No fever and no other symptoms are reported. She reports no unusual travel, just heading up to the ski towns for hiking and backpacking on the weekends. She is originally from the northeast of the U.S. and moved out to Colorado about 1 year ago. She reports the stools are very sticky and she has trouble wiping clean, and the stools float in the toilet. She does not report any blood in the stools. Now, I want to point out a few things, a few features about this case that might help us start thinking about the diagnosis. Diarrhea is her chief complaint. She's well enough that she's being seen in an outpatient clinic, not in the hospital. She's in Colorado. Starting to think about things that are present in Colorado. Foul smelling, stomach cramps, nausea, gas. And then the stools are described as floating, and she doesn't report any blood. Now, we're going to talk a little bit about the clinical disease with Giardia. I break it down into 3 different groups. There's asymptomatic exposure, and really a lot of individuals may get infected, but they'll go for periods of time without any symptoms. They'll remain asymptomatic for long periods of time, even though they're actually infected. And some of these people, though exhibiting no symptoms, can become chronic carriers and actually be passing the cyst. Then we have acute disease. Of those who go on to develop disease, the most prominent symptom is the protracted diarrhea. The acute diarrhea of Giardiasis is classically described as foul smelling with flatulence, nausea, weight loss, and abdominal cramps with bloating. Unfortunately, there's also the situation where we see chronic infections. And this is diarrhea which may last weeks or months, although it usually varies in intensity, affecting children, often leading them to have failure to thrive. The chronic infections are characterized by steatorrhea, that's a fatty stool, accompanied by malabsorption with associated weight loss, general debility, fatigue, and abdominal discomfort. Now, how do we make the diagnosis? There's really 3 main ways. The historical way that this has been done is through an examination of stool, an ova and parasite exam, looking at the stool under the microscope. Unfortunately, this requires several stool exams. It lacks a certain amount of sensitivity, and particularly the chronic people who are just passing the cysts might be missed. We moved next historically into the antigen capture ELISA, and this was originally for Giardia and a second pathogen where we could start looking at antigens in the stool. Presently, we're at, I would say, the most sensitive of these modalities, which is nucleic acid amplification tests. This allows us to have the highest degree of sensitivity for diagnosing this infection. Here we show you a stool ONP, oven parasites, a microscopic examination of the stool with the 8-micron trophozoite, as well as the cyst stage. I must say, of all the modalities, this is the most visually pleasing. We have the antigen capture ELISA. This is just sort of showing an example where we're looking for an indicator or color change, often to tell us whether or not the antigen is present. Also going to tell us to some degree quantitatively. But this is really where a lot of our diagnostics have gone when we have this available. The nucleic acid amplification tests have really improved our ability to make this diagnosis in terms of sensitivity. It's also incredibly specific, which is a great thing to have as well. Now, what about treatment? The preferred drugs would be metronidazole or tinidazole. The metronidazole, and you'll see with different diseases, we're going to dose this medicine a little differently. For Giardia, it's 250 milligrams 3 times a day, which is TID. You can do that for 7 days. Tinidazole is another option. The nice thing here is this is a 2-gram one-time dose. If we have failure, then we have another preferred drug option, which is nitazoxanide, just 500 milligrams twice a day for about 3 days. We do have a number of alternative antimicrobials: paromomycin, furazolidinone, quinacrine, and albendazole. And I want to make a point, and I'm seeing this in clinical practice as being described worldwide, is resistant strains of Giardia are increasingly prevalent. And many will need to retreat, often with a different class of antimicrobial therapy, or in some cases, a longer course of the original agents. In some refractory cases, we often have to use combination antimicrobial therapy. And just to give you a little visual here of some of the molecules that we're using, this class, the nitroimidazoles, which are the group where metronidazole and tinidazole are. One of the things I will just say, speaking of the nitroimidazoles, is we usually recommend that people abstain from alcohol while in treatment, because there is an effect where the alcohol gives you this antabuse or disulfiram reaction, where you actually get it because of the interference with the breakdown. You get almost a formaldehyde taste in your mouth. You could feel quite nauseated and ill. So for the limited period of time, 7 days, or just a few days right around the tinidazole dose, we recommend abstaining from alcohol. Now, what about our patient? Fortunately, our patient was diagnosed. This was a situation where we did stool antigen, and Giardia stool antigen was positive. Patient took metronidazole 250 milligrams 3 times a day for a week. She was told to gradually introduce dairy products, sort of slowly advance her diet as her symptoms improved. And I think it's important that we do that. With the sort of villi flattening that you see with this disease, people will develop an intolerance to a lot of food products, particularly dairy products, because the enzyme dissolving the dairy products is at the tips of the villi. So you want to, even once you've cleared the infection, you want to sort of slowly advance the patient as far as diet. Otherwise, if they think, oh, I feel so much better, I will go and have that burrito, they may end up quite upset with you and themselves. Fortunately, when this patient was seen a few weeks later, all the symptoms had resolved and she had returned to a normal diet.
Elimination of this parasite from the environment would be almost impossible, given the fact that there are reservoir hosts. That is to say, this is another animal, not human, another animal like a dog or a beaver or a deer that can acquire this infection, suffer the same way that we suffer from it. They will have diarrhea, they'll have flattening of the villi, they'll have all of those signs and symptoms, and they then serve as a way of distributing this parasite to places where people don't ordinarily go. Where people do go ordinarily, though, is to drop their kids at daycare centers so they can go off and do a day's work. And this happens to be one of those places where if one of those children has Giardia, it's very common for them to spread this infection to the other kids. 3, we have breakdown of filtration plants for drinking water supplies. And that in itself has led to major outbreaks. Finally, we have the possibility that even though we've treated people with metronidazole, they didn't get better. So it means that there's some drug resistance out there too, because that's actually been documented now. It's not widespread, but there's enough of it to show some concern on the part of the global epidemiologists that would like to use metronidazole as an intervention strategy. In some places now that's not possible. So now you have to go back to a public health approach, which is much more difficult. So now I'm afraid that we're left with 2 approaches on an epidemiological basis to interfere with the transmission, and in which most cases in developed countries is a common occurrence. That is the common urban water treatment plant. almost every city in the United States, at least, and in Canada as well, and throughout many parts of the developed world, the water treatment system works very well to limit the exposure of people to fecally contaminated water, and therefore limits the amount of disease. In the countryside, of course, we have another approach to this, and that's the outhouse. If well constructed, the outhouse is as effective in controlling this infection as the sophisticated water treatment plants. So in both cases, Giardia is sequestered and has no way of getting out. But when human feces is used as a fertilizer to grow crops, these outhouse situations in tropical regions serve as a gathering point to take human feces that's all collected in one place and then use it to spread out on their fields. And the cysts of Giardia can last for weeks under those conditions, and that's why it's a health threat. It's easy to recommend these things, of course, when you have all the money in the world to actually implement them, but in many cases, these are not possible. But maintaining safe drinking water supplies, protecting watersheds, and filtering water before you drink it is the ultimate way of controlling this. And that's why vast regions of some places are not infected with this. Maintaining good sanitary practices in daycare centers is more difficult. Little kids like to put things in their mouths. That's part of their growing up process. And that's part of the way they acquire this infection. And finally, if you're a camper and you go out in the woods a lot, you like canoeing, you like hiking, you like fishing, you like hunting, and that sort of thing. Don't be tempted by the fact that it looks clean and lovely. There could be a beaver dam upstream from where you're staying. And if you drink that water, of course, the beavers are shedding these cysts into the water just like we shed them. And you will become infected. And in fact, some places, it's so common an infection among first-time campers that the disease is often referred to as beaver fever. It's not so funny, though, when you catch it. There's an excellent update in Current Opinion for Microbiology, 2016, that I highly recommend. And a lot of this material is talked about in greater detail, so you can learn more about how the oxidoreductase enzyme is interfered with by the drugs, etc. Something more about drug resistance as well. And of course, we have our wonderful This Week in Parasitism to discuss this as well. So episode 16 features Giardia in perhaps a more conversational style than we're doing it right now, but certainly I highly recommend it. And in fact, for many of these episodes in our book that we'll be discussing, there is an equivalent TWIP episode that I can recommend for you. Thank you for listening. Next time we'll discuss leishmaniasis.